Good evening, ma'am.
Good afternoon.
Yes, ma'am.
Good evening, ma'am.
Good evening. It's actually good afternoon. Yep. Okay, good afternoon, all of y'all. So today we left off with starting a new lesson last time. So today you're supposed to have your weekly test, but you're not having it today because I haven't taken proper class for y'all this whole week, right? Because of my personal reasons and weather compatibility, I wasn't able to take classes for y'all properly. For that reason, you're not having your Sunday test today. Let's continue with from where we stopped. Prithvi, can you summarize? Can you tell me what is an acid? Were you there last night?
No, ma'am, I heard recording sessions.
Okay, what did you understand through the lecture?
Ma'am, sea breezes and land breezes are.
No, we actually started with a new lesson, acid, bases, and salts.
Okay. Ma'am, last class, quiz was there, right?
Okay, all right, fine. Okay, it's fine. Tell me what's there in class? Varshit, you tell me, what is an acid?
Ma'am, acid is an sour of the thing.
Acid is a?
Sour, ma'am. Sour.
Okay, fine. It is sour. What else is there in an acid?
What,
Some
ma'am?
acids are harmful, some acids are non-harmful. Okay. So the substance or the tool that is used for finding if an object is acidic or basic are known as indicators. All right. So the indicators, they change the color. They change the color when they add, like when you add the solution that has acid or base in it. Okay. So these indicators are classified into natural indicators, and we're going to see what are the different types of indicators. How do you find them in acid or base? So indicators are what we're going to see. The first indicator is litmus, which is a natural dye. Okay, so the most commonly used natural indicator is the litmus. You get litmus from the lichens. Okay, the color is almost like a mauve color. Mauve is nothing but purple shade. Okay, it's a shade of purple. Show you the shade.
Ma'am, can you share the screen?
Oh, I'm sorry. Just a minute. Yeah, I hope it's visible. This is only mauve color. Okay, this is the color of the litmus paper. You see, you have papers like this, and when you put the papers in the acidic or basic solution, it changes into these colors. Can you see the color band? So the different colors it changes into. Okay, so litmus paper is mauve color, and it is derived from the lichens. So when you add it into an acidic solution, it turns into a red color. And when added into a basic solution, it turns into blue color. Okay, so it is available in the form of a solution also. You get it as a form of a paper also. You get it in the form of a strip of paper like this, or you get it in the form of a solution also. Okay, so this is known as a litmus paper. Okay, and normally they're available in two colors. One is red litmus paper or blue litmus paper. Okay, so for example, you're taking a red litmus paper. You're putting the red litmus paper into an acid. What color it will change? You're taking a red, it won't change into any color. It will be neutral, right? Because it is already in red color. You're taking and putting it in a base, then what color it will change?
Blue color.
Blue color.
Change to blue color. Whereas you take a blue litmus paper, it will change into blue litmus paper. You dipping it in acid, then
Ma'am, red color.
red color, and put it in base.
Ma'am, it will not change.
It will not change. Okay, this is how you do litmus papers. All right. Now this is the first indicator, the litmus. Then you have a second indicator. It is the turmeric that your mothers have in your kitchen. No? Turmeric. This is another natural, also another natural indicator. Now, for example, you're taking a tablespoon or a powder of turmeric powder. You're adding water into it. You're making it into a paste. You make the turmeric paper by putting just taking a piece of paper, white paper. You're going to fill it. You're going to blot the full paper with turmeric. You're going to cut the strips. You'll have yellow strips of paper. Now we're putting a drop of soap solution on the paper. Okay. What color do you think it will change into? It will change into a. Any guesses?
Ma'am, can you repeat again?
You're taking a piece of paper. You're going to blot it in turmeric. This is the turmeric paper. You're going to add soap solution to it. What color will it change?
Ma'am, color.
Any guesses?
Blue color.
Red color.
Red color. Very good. It changes red color. Why?
Ma'am, because the soap is an acidic solution.
Okay, so soap is acidic. So it changes into red color. Adrit is, sorry, who's saying it? Adrit, you know? I get the wrong name. Anubhav, sorry. Anubhav. What about Varshit and Krithik? Tell me.
Ma'am, because it's glycerin, it's made up of glycerin.
It's made up of
Ma'am, it's made up of glycerin.
glycerin. No. What I'm asking is soap acidic or basic?
Ma'am, I'm thinking basic.
Ma'am, basically.
Basic. Right. So, Anubhav, correct yourself. Soap is basic in nature. It is not acidic. Why? Because we've already told you in the start of the lesson, basic always have a soapy texture. Acids don't have soapy texture. Okay. So in turmeric indicator, it is the other way. Okay. So basic solutions turn into red color. Turn the turmeric paper into red color. And acidic solution, there is no change. That is, it will stay yellow itself. All right. Now I have another third indicator. First, take note of this. Make note of till here. Tell me when you're done. Tell me your name and tell me when you're done.
I have done. No.
Okay.
Ma'am, Varshit completed.
Okay.
Ma'am, me too.
Okay, so all of you are done. Kritvik also done?
Yes, ma'am.
Okay, all right. So we're going to see another indicator. That is China rose.
Ma'am, hibiscus.
Yes. Okay. So China rose is basically just going to take hibiscus. You're going to get the juice of it. You're going to grind it. Okay. So so color of the solution will be in China rose solution will be in
Ma'am, like purple color, ma'am.
purple color. Hibiscus is purple color.
No, ma'am, when we
Red color.
Red color. So the juice will also be in red color. So it's basically a red solution. Okay. Now this red solution. Tell me the changes of color. Guesses first, Kritvik.
Ma'am, for acidic or
Yeah.
ma'am, blue color.
Okay. Kritvik is saying blue. What about the Anubhav?
Ma'am, I think also blue.
Okay. Varshit.
Ma'am, I also think blue. ma'am.
Hi Kritika, why are you late to class? Kritika? Kritika, am I audible? Fine. So actually the changes are acid solution turns into dark pink. And basic solution turns into green. So you'll have to learn what indicator changes acid solution to what color and basic solution to what color. All right, so you got to do that. Okay. Just make note of this and we'll go to the next part.
Ma'am, no.
Okay, what about the rest?
1 minute, ma'am.
Yeah.
Ma'am, done. ma'am.
Okay. Nashid done.
Ma'am, done.
Okay. So Now you know that acid turns to one color, basic turns to one color. Now what happens when you mix acid and base together? What happens when you mix them?
Ma'am, I think it becomes purple color.
I'm not asking the color. You call a solution as acidic, or you call a solution as basic. When both of them are mixed together, what will you call the solution? Acidic or basic?
Ma'am, salt.
Okay, Varshit is saying salt. What about the rest? Okay, so first thing, when acid and base is mixed together, both two strong substances are being mixed together. So heat will be produced. You take a test tube, you're adding acid and base, the test tube will become a little hot. So heat is produced. And this solution is called as a neutral solution. It's in between. It's not acidic nor is it basic. Neutral solution. Okay. So the process here is called as neutralization. All right, it's called as neutralization. Or okay, so during neutralization, as Varshit told, it's the solution is not called as salt, but salt is produced over here. So always during neutralization, salt is a product that is being formed. Okay, so in neutralization reaction, always a new substance is formed, and this new substance is called as salt. This salt can be acidic, basic, or neutral in nature. Okay, so how will you define neutralization? Neutralization is the reaction between an acid and a base is called neutralization. Salt and water are produced in this process with the evolution of heat. So this is called as a neutral solution. Along with salt, water is also produced. It's a neutral solution. I'm writing the definition for what is neutralization over here. So basically, acid plus base is equals to salt plus water along with, this is the equation. All right, now I'll just give you an example. There's a solution called hydrochloric acid, which is in your stomach, right? So it's HCl, hydrochloric acid or HCl. Okay. Along with, HCl is acidic or basic?
Acidic.
Acidic.
And then you have sodium hydroxide, that is NaOH. So when an acidic and a basic solution is being produced over here,
Excuse me, ma'am.
yeah, tell me.
Ma'am, I have an internet issue here, so I didn't get it told, like from the starting word. What happened in the class?
Okay, you had another class.
Yes, I just I can't hear. Like I have an issue with my speaker, so I can't hear anything, and also I have some network issue.
Okay, not an issue, not an issue. Just concentrate on whatever I'm taking right now. And you can refer the lecture which is recorded. Okay.
Okay, ma'am.
And after watching the lecture also, if you don't understand, please text me privately. I'll just explain it to you next class. All right.
Okay.
So HCl plus NaOH gives you this NaCl. It will become NaCl plus H plus O2 is H2O. H2O means what? Water. So this is a salt, this is a water. This is an example of the equation. So please know the chemical that you're writing. First one is hydrochloric acid. Second one is sodium hydroxide. And this becomes sodium chloride. This is water. Please make note of it.
Mom, Dad.
Okay.
Ma'am.
Okay, all of you are done. Anyone left?
Ma'am, I'm right.
Yeah, tell me when you're done.
Ma'am, is there any notes before this?
Yeah, tell me when you're done. I'll show you that page.
Okay, ma'am.
Ma'am, NaO, which means sodium hydroxide.
Yes.
Completed, ma'am.
Okay, I'll take make note of this also. I think you were there in the last class when I taught you this. Were you there?
Yeah, ma'am, this is completed. I
Yeah.
completed.
Make note of this.
Yes, ma'am. Ma'am.
Nada.
No, like after after in turmeric, like after basic in acidic, like I can't understand the word after that. After that, in
One.
ma'am, no change.
This one.
No, ma'am, this one, this one. After acidic.
No change.
Okay. Completed.
Okay, all right. So you all are very familiar with all the four indicators that we taught so far. Okay, any doubts so far?
No, ma'am.
Okay, we saw neutralization and we saw an example of neutralization. Now we'll see a small video for better understanding of neutralization. Okay.
Wash after wash, metal penetrates inside your hair. Innovation, Metal DX. Remove metal for 97% less hair breakage, true to tone, long-lasting color. Hair is stronger, 2 times shinier. Metal DX by L'Oréal Professionnel.
If we take two solutions, one acidic and the other alkaline, and mix them, what will be the result? By now,
Alkaline is nothing but basic, okay? So make note of it, write in like in bracket or something. Other word for basic solution is alkaline. Alkaline is nothing but salty.
you should be able to answer that it will give us a salt and water will be released as a byproduct. Now, does this happen every time? I mean, will an acid and an alkali always give us salt and water? Yes, it will always be like this. An acid, when combined with a base, will always give us salt and water. And what is this reaction called? Does it have a specific name? Yes, it does. It's called a neutralization reaction. Here, the strength of both the acid and the base are lowered. They are brought to a neutral point where the intensity of the acid as well as the base are dropped lower. The best example to study a neutralization reaction is the formation of sodium chloride, or simply put, common salt. If we take hydrochloric acid and combine it with sodium hydroxide, then the neutralization reaction gives us sodium chloride and water is obtained as a byproduct. The reaction also liberates a lot of energy in the form of heat. This is how every neutralization reaction works. Acid and a base combine to give salt and water with heat generation. But looking at the reaction of sodium chloride formation, you may say that neutralization only occurs in laboratories. When acids and bases are combined in a test tube in a lab, it's only then a neutralization process occurs. Is that the case? Actually, that's not the case. Neutralization reactions are a part of our daily lives as well. Many reactions occurring inside our body or even throughout the day are neutralization reactions. For example, we usually find elders complaining about acidity or ants biting us on the skin. These are examples where the percentage of acid increases inside or on the body compared to the normal value. Such cases are treated with medicines. But have you wondered how these medications work? Needless to say, they work based on the principle of neutralization. Next, let's have a glance at the various examples of neutralization reactions in everyday life.
Are you someone who wants to build a career in core finance but finds CA extremely tough or finds MBA very complex?
If we are given lemon juice and soap water in two different beakers, will we be able to list the difference between the two? Perhaps the list will begin with the different colors, appearance, and so on. But these are just properties that we can see. Are these the only differences? There are more. Lemon juice tastes very sour. Soap water tastes slightly bitter. Please don't try to taste it. Just trust me, it tastes slightly bitter. Is this a major difference between the two? Yes, taste is an important parameter as it takes us to the chemical properties. Why does lemon juice taste sour? And why does soap water taste bitter? Any idea? The answer lies in their nature. Lemon juice is an acid while soap is a base. Do you know what an acid is and what a base is? Let's get to know these terms first and later get into their details. To begin with, we have acids. The moment we hear the term acid, something scary or something that would burn the surfaces is what pops up in our mind. Well, that's kind of true, because acids are known to create a burning effect of whatever comes in contact with them. They can erode the surfaces or burn the skin when they come in contact with it. That's how acids are. The term acid comes from the Latin word acidus, which means sour. Yes, so are all acids sour to taste? Yes, they are. The intensity of sourness may vary in different acids. but the overall taste of acids is always sour. The best examples of substances that contain acids include citrus fruits like orange, lemon, lime, and grapes. Now let's talk about the soap water. What nature does it have? It is basic in nature, which means soap is a base, or in other words, an alkali. What do we mean by this? For now, all we need to know is that the mild bitter tasting compound is called a base. Bases, when added to water, give foam and feel soapy when touched. Bases are exactly opposite to acids. The best examples of bases include baking soda, washing soda, quicklime, and many more. This was about acids and bases in general. Now can you tell me what will happen if an acid and an alkali, as in a base, come together? Will the solution explode? Will it give an unexpected reaction or something else? Well, it is something that we already know. Imagine we mix a strong acid like hydrochloric acid with a strong base like sodium hydroxide. What will be the result then? The reaction yields sodium chloride and water. Sodium chloride is the common salt used by us. So, an acid with a base gives us salt and water. This is a generalized reaction. Salts are the product of reaction between an acid and a base. But now tell me one thing. How do we understand whether a compound is acidic or basic? Can we taste it every time? If we are given a solution of concentrated sulfuric acid, how are we supposed to know its nature? It's not possible to bear even a drop of it on your skin. So tasting the solution is just out of the question. So now, how do we say that this is an acidic solution? There has to be a way to figure it out. The solution has to undergo a few tests. The substance used to check whether the compound is acidic or basic is called an indicator. The indicators indicate by changing their colors. Indicators, when added with acids or bases, show a change in color. That is how it becomes convenient for us to find out whether the compound is acidic or basic. But what kind of substances are used as indicators? Next, we will look at the various indicators.
Okay, I hope it is clear for you. I just gave a small recap of our last class and what was taught today. So we're going to see now all the different types of neutralizations that happens in our everyday life. All right. So first thing that we're going to see is indigestion, or what do we call is acidity. What is acidity? Definitely heard this term somewhere. What is it?
Ma'am, the increase of acid in our stomach.
Very good. It's basically the increase of acid in your stomach. Okay, this is when you either eat food after a very long time or you don't eat food, okay, at all. So what happens, all this acid starts accumulating or piling up in your stomach. What is the acid in your stomach?
Ma'am, HCl.
HCl. HCl is the acid that is in our stomach. So HCl adds on, which causes acidity. So you need to add a base for the solution, and the base is there is eno and all, right? Eno powder and all that. It's like a white powdery substance to mix with water and drink it. So that kind of substance is basic in nature, and you drink something called as the milk of magnesia. That eno itself, that is called as milk of magnesia. Okay, so too much of acid in your stomach will not allow your food to digest very quickly. Okay, so this will lead to indigestion. Okay, sometimes indigestion is also painful. You get stomach ache and all. For relieving this, we take an antacid, which is called as milk of magnesia. This contains magnesium hydroxide. You all should be aware by now. If the term hydroxide itself is there, it means it's base. Okay, here we saw that. Okay, so you drink that, and this will neutralize the acid. It will calm down the acid. Okay, and it will basically remove the acidity, and it will bring down the power of the acid. This is one of the situation. Second situation is when an ant bites. So what happens to your hand when ant bites?
Ma'am, it feels itchy.
It feels itchy and it will become red in color, right? So when an ant bites, it injects. What happens? An ant what it does is it injects an acid. Okay, so it injects an acidic liquid. This liquid is known as formic acid. Okay, into our skin. So the effect of the acid will create a burning sensation or itchy sensation. All this. So all this is neutralized by adding a base, and the base that you use here is by using baking soda. You apply baking soda, the etching will go down. Okay, baking soda's chemical name is sodium hydrogen carbonate. Or NaHCO3. This is the chemical formula. All right. Or another solution other than baking soda can also be used, which is known as calamine solution. This calamine solution, it contains another salt which is called as zinc carbonate. Okay, please take note of this. One minute, guys. Tell me when you're done.
Done, ma'am.
Yeah.
Ma'am, done.
All of them are done. Anyone left?
Ma'am, 1 minute. Done, ma'am.
Kritika, are you done?
Yes, ma'am.
Okay, all right. So another situation of neutralization is in soil treatment. So you need a proper soil acidity level in order for it to be treated. Okay, so excessive use of chemical fertilizers. So more use of chemical fertilizers will make the soil acidic. Okay, so plants do not grow well when the soil is too acidic or too basic. So when the soil is too acidic, we add bases. So in case your soil is acidic, you add a base, and the base is called as calcium oxide, or it's also known as slaked lime. Calcium oxide is also known as slaked lime. Okay. So sorry. Calcium oxide is a different one. Slaked lime is a different one. The chemical name for slaked lime is calcium hydroxide. All right. So if the soil is too basic, then you will add an acid, which is what do you say? An organic compost, basically. Peelings of fruits, eggshells. Okay, so the soil is basic, organic compost is added to it. So in organic matter, they will release acid, which will utilize the base. So what do? They release acid. Okay. Finally, in the last example, we have factory waste. So what happens in factory waste? So the wastes of many factories, they have acid in them. Okay, so factory waste, they have acid in them. Okay, so if they are allowed into water bodies, all these acids will, what they will do? They will start killing the fish and other organisms in water. So the factory acids, they, before like making them or adding them in wastewater, they have to be neutralized. This acid is dangerous. They have to be neutralized before discharge into the water ponds or anything. Neutralized by adding a basic substance. Okay, please take note of it. And with this, we complete our lesson. Next class, we'll have a small question answer session. That is tomorrow. I'll upload the notes. So please make note of it. And as soon as you're done taking note of it, you can leave the class. Thank you. Any doubts?
No, ma'am.
Completed.
Okay, you can leave the class. Thank you.
Bye, ma'am.
Bye-bye.
No, I'm done. I'm done.
Bye.
Yes.
We got home. Huh? Oh, you're not coming.